we introduced the topic, we solved some examples after looking at the first 6 trigonometric functions, that is sine, cosine, and tangent. We also added cosecant, secant, and cotangent. Now, to understand the reasoning behind, we simply want to define those 6 functions, trigonometric functions, in terms of x and y. Now, to do so, on the x or y plane, this that you are able to see, let's say in diagram A, this one, we have a right angled triangle, we have a theta there. Now this triangle, a right angled triangle, has some movement in the x-axis from the origin, has also some movement in the y-axis, right? Now we have the point P there. Okay, let this be the point P at this point from the origin. Now this point is the point xy, right? It contains the y and the x value, as we can see. Now the distance between the origin and the point P is equal to r. Okay, this is r here, right? We have the theta there, and so we can use now the movements in the x-axis and the y-axis, or rather the distance, to define the 6 trigonometric functions. Let's start with sine, right? Let's start with sine theta. If we want to define sine theta is equal to opposite over hypotenuse. Now in this case, in terms of x and y, this will be our opposite from the diagram. Remember, this is r. Okay, now from the diagram, our opposite is y, right? Our hypotenuse, that's r. Okay, this is r. Now we can define cosine, right? Now cos theta is equal to adjacent, right, over hypotenuse. Now our adjacent is x, our hypotenuse, that's r, right? Now we also have tan. We have tan theta is equal to x, right? Sorry about that. Tan theta, that's opposite over adjacent, which is y over x, right? Now we can also define cosecant, which is cosec theta, right, is equal to, that is cosec theta is equal to hypotenuse over opposite. Our hypotenuse, that's r, over our opposite is y, right? Now there's something that, okay, I'll remind you on that one. Let's go to secant. There's something that I want you to see here, which will help you understand these functions. We have sec theta is equal to r over x. That's r over x, right? Now we have cotangent, abbreviated as cot theta, is equal to, now cot theta is equal to x over y, x over y. Now I want you to note something, okay? You can say that cosecant is the reciprocal, right? Cosecant is the reciprocal of sine theta. Sine theta is y over r. Cosecant theta is equal to r over y. Hence, cosec theta is the reciprocal of sine theta. The same thing applies to cos and secant, tangent and cotangent. Okay, now we can use Pythagoras theorem. We know that from Pythagoras theorem, if we want to find r, sorry about that, if we want to find r, right, we can say r squared is equal to x, that's the movement in x, plus the movement in y. Now this can also be written as r, okay, let me just write it here, that's r is equal to the square root of x squared plus y squared, right? Okay, so this is what we can do to find r, that is the distance from the origin to point P. And so we have defined the 6 trigonometric functions in terms of x and y, x, y, and r, and also we have defined what r is. Okay, now we can apply this definition in this example that we have, right? So in this example, we've been given that a point P has the x value 5 and the y value -3. Okay, now I want to find the exact value of any 3 trigonometric functions of the 6 trigonometric functions. So we just need to make a choice of 3. There are 6, as we can see. Now we just want to use this example and solve 3 of them. The rest you can still use the same procedure and you're going to find the same answers. What is important in mathematics is just to get the concept and then know how to apply it. And so let's do that. We can start by applying this to sine. We know that sine theta is equal to, from the definitions above, sine theta is equal to y over r. Now, do we have r? No. Do we have y? Yes. From the point P that we have been given, we know that 5 is the x value and -3 is the y value. And so we can find r. We know that r is equal to x squared, right, plus y squared. Now substituting, we are going to have, that's 5 squared plus -3 squared, which will be equal to square root of 34, right? So since we have r, then we can solve, or we can find out what sine theta is with the point P. So our y is -3, our r is the square root of 34. That's if we want theta, the size of the angle there, with the movement in the x-axis and in the y-axis by 5 and -3, we are going to have sine, or the inverse of sine, and what we have there inside the brackets, that's -3 over the square root of 34. If you use your calculator, you're going to find the size of this angle, right? We can also apply this same concept to tangent, right? Tangent theta. We know that tangent theta is equal to y over x. Now what is our x? Our x is, we can, that's y. What is our y value? That's -3. Our x value is 5. That's to find the size of the theta. this will be tan inverse negative 3 over 5. You can use again your calculator and you're going to find the size of that angle. There we can use sec, that is secant theta is equal to, okay, that's secant theta is equal to r over x. Right? Now what is our r? Our r, that's square root of 34 over our x value, that's 5. And so we can also find the theta, the size of the theta. The size of the theta is equal to sec (34 over 5). Okay. Okay, so we have that. Now we can proceed. Okay, for now we can just end here.